In this part 2 of OCI, Oracle Cloud Infrastructure, we will learn about some basic concepts of VCN, Subnet, IP Address Insider, Internet Gateway, NAT Gateway, Service Gateway, Local Peering Gateway, Remote Peering Gateway, and Dynamic Routing Gateway. So we all know that about one of the important concern in cloud is about the security, right? And so uh, we have to control the traffic, even it is traveling inside the cloud from one place to another place, or maybe from one server to another server, or maybe it is traveling from cloud to outside world, or maybe it is traveling from outside to cloud world. So we have to make sure that the traffic or the data that is moving out, okay, it should be secure. So gateways are, you can say, about intermediate component, okay, that allow the flow of data between the different components, which is maybe inside your cloud or maybe outside the cloud. Okay, for example, maybe you have some applications running on premise in your own data center, and then you want to have a connectivity with some of the services those are running in the cloud. Okay, then you have to transfer your data from your on-premise to your cloud, or maybe in reverse order as well. You may need to transfer your data from cloud to your on-premise, right? And maybe inside the cloud as well, you want to transfer your data from one subnet to another subnet, or one VCN to another VCN, or maybe from one region to another region. So it's all about how your data is transferred and how it is gets secured. So to provide a different kind of a connectivities between the different mediums, okay, there are different kind of gateways are there. Okay, and then another important concept is about how we can define the IP addresses for the machines or servers those are running in the cloud. Okay, that is part of your subnet and VCN as well. So let us begin with first understand the IP address, okay? Because that to understand the IP address is you can say it's a very critical area if you are going to understand how you can create the VCNs in your cloud, and then how you can define the CIDR block for your subnets and some different components to assign the IP address to your machine. So it is important to understand the IP address format. Okay, so IP address, or you can say about the IPv4 IP address. Okay, it is called as 4-octet 32-bit IP address. Why we called it as a 4-octet or a 32-bit IP address is that we all know that the generic format of your IP address is about in a 4 place, x dot x dot x dot x. Okay, for example, there's an IP address 192.168.0.1. So all total we have 4 octets, right? 1, 2, 3, and 4. So we can say it is a 4-octet, okay, because we have 4 places there, and each octet is of 8-bit in the IP address. So all total we have 4 octets, and we have each octet of 8-bit. That means we have total 32 bits in an IP address. So that's why we call it as a 4-octet and 32-bit IP address. Now, a few more important points about the IP addresses is that 32-bit address contain 2 primary parts: the network prefix and host number. So what exactly it means that once we have some server running in your network, okay, and then that server need to be identified uniquely, whether it is in your local running in your local network, or maybe it is running on the internet, or maybe it is accessible from the internet that is available for the outer world, right? So n number of machines are there in the world, right? And then if one machine is sending data to another machine, then you need a unique identifier. That means we need a unique IP address for the machine to identify. So if it is in the outer world, or if it is exposed to the outer world, then you need an unique IP address for the public world. You can say for the public network. Okay, and if it is running even inside your network as well, then again you need a unique identifier to identify the each and every host uniquely. So all hosts within a single network share the same network address. So in an IP address, you have to identify a machine with the help of network address and then with the host address. Okay, so because there are n number of networks are running in the world and even in your organization as well. So how you identify a machine or server in the network with the help of IP address is that the initial part of your machine is a network address, in which network it is running, and then inside the network, what is the identification of that particular machine or the host, and that is called a host number. So an IP address is a combination of network prefix and the host number. So all hosts within a single network share the same network address. So if it is in the same network, then it has to be a same network address, right? And each host also has an address that uniquely identify it. As I said, each host will have to identify uniquely. That means a unique host number is there along with the common network prefix. And depending on the scope of network and the type of devices, the address is either globally or locally unique. So global in the sense, if your machine is exposed to the outer world, okay, then you have a unique IP address, which should be unique across the globally, right? And if it is your internal network, then maybe in internal network you have a 20 50,000 of machines are running, then every machine need to be identified uniquely internal as well, right? So that is a private unique address for you. Okay, and device that are visible to users outside the network, for example web server, must have a global unique IP address. Okay, this is the same what I said, that if you are exposing your machine to the outer world, then your machine need to be identified uniquely. For that, you need a globally unique IP address. And devices that are visible only within the network must have your locally unique IP address. Now, in the traditional IP address format, how we assign the IP address to machines, we have initially we had three type of IP address schemes: class A address, class B address, and class C. Okay, so what exactly, how we define IP addresses in all these classes is very simple. Class A address use only the first byte octet to specify the network prefix, and leaving 3 bytes to define individual host numbers. So we have 4 octets in the IP address. So in class A address, the first octet is reserved for the network address, and rest 3 are open to assign to your host. Okay. Similarly, in class B address, you have initial 2 octets are reserved for network address, and then rest 2 are uh, reserved for the host. And class 3 address, first 3 bytes, or sorry, you can say first 3 octets are reserved for the network prefix, and the last octet is available for the host. So what exactly it shows is that uh, the number of octets that is available for the host in a particular IP addresses. That means in that class network address, you can define many IP addresses, or you can have a many. You can say you have a n number of hosts that you can assign the IP addresses, or you can say about the number of hosts will be large in class A address, because only first octet is reserved for the your network prefix, right? As we go to class B, then you have 4 octets to assign to your host that you have. That means again you have us. When I compare with the class A address, then you have a class B address which comes on the second level, okay, where you can define the different host and then IP addresses. And then in class 3, we have a less number of hosts, because in there you have only 1 octet is reserved for your to assign to the host. So if you have only 1 octet that is there to assign to the host, that means you have a less host, or you can say less IPs to assign to the host in comparison with the address A and address B, right? And then if you wanted to count the number of hosts that we can assign in class A, B, and C IP addresses, then how we can do it is that, because in an octet, if I go to class A, in class A you have 3 octets. 3 octets are available to assign to host. So each octet is of 8 bit. That means you have a 24 bits there, right? Because each octet is of 8 bit, and I'm saying that 3 octets are available for the host. That means you have altogether 24 bits are available for your host. And then how to count the number of hosts that I can assign the IP addresses, you can say it is a math calculation. You can say about 2 raised to the power 24. So 24, why 24 for class A? Because we have 3 octets reserved for the host, right? So each octet is of 8 bit. That means you have a 24 bits, right? So that means you have altogether you have 24 bits available for your host. So you can calculate 2 raised to the power 24. If you are not clear on what it means 2 raised to the power of 24, that means you can multiply 2 24 times. Okay, and it will come to 16777,216. Okay, so these are the possible number of hosts that you can define in class A address. Similarly, if I go to class B address, so in class B address, you have 2 octets that is available for the host. That means you have to all together 16 bits there. So you can say 2 raised to the power 16 is 65536 number of hosts. And if I go to class C, there are only 8 bits are available. 1 octet, that means 8 bits are available to assign to the host. That means 2 raised to the power 8, which is called 256. That is the number of hosts that is available in IP address scheme. So this is basic about the IP address and how we can define the IP addresses and the total number of machines that I can assign to a particular class of address. Okay, and one of the drawback is that we sometimes, or many times, our IP addresses just get you can say lost, or we can have a the number of IP addresses that may not be in use in particular IP addresses. So, okay, so that is one of the drawback of this kind of a scheme. So overcome to this, now we in a cloud, we define IP addresses in the form of CIDR, which is called as a CIDR block. So now let us come to the basic concept of our cloud, okay, and the components that we have discussed in the agenda, okay. So let us see that there's a OCI cloud, okay, and this is in the region Sydney, okay. And inside that, when you work with the Oracle Cloud infrastructure, one of the first step is to set up a virtual cloud network for your cloud resources. So if you are going to work in a cloud or you are going to create any resources in your cloud, okay, the first thing that you have to define is that you have to create a VC, and that is called a virtual cloud network. So it is a separate network, okay, just like you have an on-premise, then you have your own network in your on-premise. Similarly, is a cloud, right, where it is maintained by a cloud service provider, and then there are multiple n number of customers are there, right, in the same cloud. They may be sharing the servers or the resources, or they may not be sharing based on the model that you have taken, but at last they all are running inside the cloud, right, where you have all the customers are there. So to protect your resources from the other customers or maybe from the other tenants, okay, you have a concept that is called a VCN, which is a virtual cloud network. Okay, this is a network that has been assigned to your resources only in the cloud. So first you have to define a VCN. Okay, maybe suppose that you have defined a VCN with name prod VCN, where you will have your all the infrastructure or resources that you want to assign to prod production live environment. Similarly, you can have another VCN as well. For example, you can have another VCN for your pre-production servers. You have another VCN for your non-production servers, right? And then inside the VCNs, what exactly you are going to do? You are going to create different machines, right? Servers or instances. And to all the instances or servers, you need to assign certain IP addresses, right? So to assign an IP address to your machines, okay, we defined the IP address scheme as a CIDR blocks. So how it is defined? It is defined in the form of IP address and a slash then octet. Okay, for example, 192.168.1.0/28. This is the scheme that you will define for in the CIDR block. Okay, so how we can say that the number of machines could be possible in this CIDR blocks with the IP addresses, or you can say how many IP addresses would be possible in this CIDR block. Okay, so we know that we have altogether 4 octets in the IP address, and each of 8 bits. So you have altogether 32 bits, right? And in CIDR block, what we have defined is /28. So you can simply minus this 28 from the 32 bits or 32. Okay, it will come as 24. So now you can say about the number of IPs would be possible are 2 raised to the power 4. And what does it mean 2 raised to the power 4? You have to multiply it to 4 times. That will come as 16. So with this CIDR block, the total number of IP addresses possible is 16. And you can also say that in this particular VCN, you can create 16 servers, or you can create 16 resources to those you can assign to an IP addresses. Okay, if your all the 16 IP addresses get exhausted, that means you have created 16 instead of servers, then further you will not able to create any machine or resources that need an IP address in this CIDR block, or you can say in this VPN, until unless you will increase the capacity of CIDR block. And this IP could be public or private. So why it is public? If you want your machine to be accessed from the outside world, then you can assign a public address. But if you want that your machine to be accessed internally only, then you can define its IP address as a private IP addresses. Second term after VCN is that we have to define the subnet. So subnet is a grouping of resources inside a VPN. Okay, and you could have an n number of subnets inside your VCN, and then a subnet can be a public subnet or private subnet. As I said, you can define a public IP address to a server which need to be accessed from the outer world. So that machine or server that you have assigned public IP, you can define inside a public subnet, and the servers, those you want to be accessed internally only, those you can define in your private subnet. So first thing, you have to create a VCN. To VCN, you have to define the CIDR blocks, and then after that, you have to create a subnet, which is a grouping of resources. Similar to, you can have an n number of subnet inside a VCN. For example, you want to have a subnet only for the empty, where you are running the middleware services, softwares, and then you need a separate subnet for your database, and then you need a separate subnet for public servers, right, where you allow to the traffic to be come and out, go and outside from internal as well to the outer world. So for that, you can define a public subnet, and suppose that you have some Windows machine as well, then you can define a separate subnet for them as a Win subnet, that is called a subnet that is specifically designed for the Windows, right? Similarly, you can have other subnets as well. Okay, but important thing is that to all the subnets, the number of IPs possible is only 16, because to the VCN you define the CIDR block 16 and all the subnets are inside your VCN. So altogether in all subnets, you can create the resources which is limited to 16, because you have the limitability, or you can say you have the capacity of your CIDR blocks is only 16. So inside your empty subnet, again for a subnet, you can define a CIDR as well. Okay, CIDR, that means, because as I said, altogether you can have a 16 number of capacity, IP address capacity for your CIDR block or the VCN, but inside VCN you are defining a different subnets, right? So that means in each subnet you will have to define a CIDR, the number of IPs or the resources required inside the subnet. For example, empty subnet. Okay, and then in empty subnet, that means you are going to define the servers. Okay, and in servers, you will have IP addresses, right? So maybe you have only 4 empty servers required in your empty subnet. Okay, then you can have a CIDR 192.168.1.0/30. So 30 is there. That means 32 minus 30 equal to 2, and 2 raised to the power 2 equal to 4. So that means in empty subnet, you will have the 4 servers, because you have the capacity of 4 IPs in that subnet. Similarly, you can define the CIDR block for your DB subnet. If you have only 1 or 2 servers are there for public subnet and Win subnet, you can define the CIDR block. Okay, so you can say the CIDR that you will define inside the subnet is a subset of your CIDR blocks, because the total capacity is, allowable capacity is about 16, and then the 16 capacity you are further dividing in your other subnets, right? And inside the subnets, you have servers, right? And then server, you can assign public IP or private ID based on your requirements, right? And for example, if you need a connectivity between different VCNs, for example, you have production VCN, which is a live VCN where your production environments are running, and you have a pre-prod VCN where your pre-production servers are running, and then maybe your non-production servers are running, and sometimes you need a connectivity between VCNs. For example, you want to refresh the data from your production to your development environment, from your production to pre-prod environment, and maybe you have done certain code changes in pre-production that you wanted to copy in your production environment, then you have to create a link between your all the VCNs. Okay, and that link between the different VCNs inside a particular region or inside a particular, you can say about your resources. Okay, that for that you have to use LPG, that is called a local peering gateway. So you have to create a local peering gateway between your VCNs where you want to have a connectivity. And if, as I said, that you may want certain services that need to be exposed to the outer world. So maybe you have a web server is running on some server, okay, and from there you wanted to allow the outer world to access your website. Okay, that means that server will be running inside some subnet with the public IP address, and if you want to allow the connectivity of the outer world, for that you have to use the internet gateway. Okay, so maybe yet in a certain subnet you have a server where a physical server or maybe virtual machines where you are running your web server, and to allow that web server to connect to the outer world, you have to define, or you have to create a resource in that OCI that is called an internet gateway. Okay, and similarly, if you suppose that you have a private server, okay, maybe a server with a private IP addresses, okay, and that need to access the internet. Okay, so what I'm saying is that your server, which is inside the cloud, that need to access the internet maybe for some services. For example, you have a database server that where you need to download certain patches, okay, for patching your database, okay, maybe from the internet. Okay, so that means some cases are there where you need your private servers to access the internet. Okay, but it is not in the reverse case. That means your internet, any traffic from the internet will not be allowed to access your private server, but your private server need to access the internet, right? And without public IP, right? So we don't have a public IP there, but still, what I want is that I want to access a server which is in my with my private IP to access the internet for some kind of a services. In that case, you have to define or create a network address translation NAT gateway. Okay, so what is the need of NAT gateway? If your server with private IP want to access some services from the internet, then you have to define a NAT gateway. Then this is a one-way traffic, only from inside to outside, and from outside to inside it is not allowed. So two-way traffic is only possible with the internet gateway, where you have a public IP assigned to your servers. And maybe you need a connectivity with your on-premise network. Okay, maybe you have some services running in the cloud, and then OCI cloud, and some services are there on the on-premise network. For example, you have softwares and websites are running on your OCI cloud, and then your database is in your on-premise. Then you need a connectivity between your cloud and then your uh, on-premise network as well. So for that, you have to define a DRG, that is called a dynamic routing gateway, and that will allow a connectivity to your on-premise network. And at last, if you have, suppose you have wanted to have a connectivity with another region, okay, for example, you have another region that is in Frankfurt, okay, and you have OCI cloud where you have resources in the Sydney, and you want to have a connectivity between different regions. For that, you need a remote peering connection with the different region, but that remote peering connection will go from the DRG. So in a nutshell, you can say about that, if you want your VCN, or if you want your resources from one region to connect with another region for any kind of a services, like maybe to copy the data from one region to different regions. Okay, for that you need to configure a remote peering connection. Okay, and that will connect to DRG. Okay, so that means you have to create a DRG, and after DRG you have to create a remote peering connection, and with the help of that you can able to connect with a different region, right? And the last one is about if you wanted to have your VCN or resources to use certain supported services in the Oracle service network, like object storage. For example, your database, which is in private subnet or private network, need to be take the backup and then copy that backup in your storage, object storage. For that, you have to create a service gateway. Okay, and that your service gateway will connect your network or your VCN to your supported service in the Oracle network services. Okay, and then with the help of that, you can transfer your data. So this is all about the basic concept of OCI networking. Okay, if you like this video, don't forget to subscribe my video, and I will come up with the more videos shortly. Thank you very much for watching this video.